Hi everyone, in today's tutorial we are going to walk through my AutoBuddy project. AutoBuddy is a car shopping search chatbot designed to assist users in finding the perfect car based on their preferences, budget, and specific criteria. In this project, we aim to develop a domain-specific chatbot application that utilizes a large language model for natural language processing, combined with the efficiency and scalability of a vector database for data storage and retrieval. The application will implement the advanced RAG method to enhance the chatbot's ability to provide accurate and relevant responses. We also fine-tune GPT-4o mini model in this project with related data to achieve optimal performance. For developing, I use Python language. For user interface, I use Streamlit, LangChain, and RAG for query processing, and OpenAI API for response generation. Finally, I use Pinecone for vector database. In data collection phase, which was one of the most important part of my project, I use web scraping method to extract cars information from various online car company and dealer inventories websites. So let's look at the code. First, I gather a list of all cars model available in Canada, which was almost 400 models. Then for each models, I use web scraping method to extract and collect information like model name, year, full efficiency, and other features. After that, I put all this information into text file and it's prepared for the next stage. So let's look at our RAG pipeline implementation. After gathering data, I split them to some chunks using text splitter and with Hugging Face embedding library. I embed all chunks and store those indexes in my vector database. So after user enter a query, our system retrieve relevant documents and as a context combine with the user's query and feed to our fine-tuned large language model to generate response. To improve my RAG pipeline and the performance of our chatbot, I focus on key index retrieval methods. I use auto-merging retrieval. Auto-merging combines multiple retrieve contexts to generate a more comprehensive and relevant response. This approach is particularly useful when dealing with diverse or overlapping pieces of information. When it comes to generating a large language model, there are always a half possibility of lack of knowledge. Sometimes the model doesn't know about a topic because it hasn't been trained on that specific data. Fine-tuned model offers get better responses with lower cost and a faster model in a specific task. So let's dive into the fine-tuning steps. First, we need to prepare the training data sets. We have to create an array of JSON files. Each record in dataset is a JSON object which contains a key called message that represents a single turn in the conversation, and these contain a role and content. Content holds the text of message, which can statement, question, or response depending on the role. So after that, we need to upload our training file for fine-tune. Next, we need to create a fine-tune job, and after initialing a fine-tuning job, it may take some time to complete. We can check the status of our job with the following Python script. So let's back to the PowerPoint. Each RAG pipeline has three main parts: query, context, and response. The query is the user input. The context refers to the retrieve information based on the user's query, and the response is the large language model output based on the user's query and the context retrieval. Based on this structure, we can evaluate a RAG pipeline in two key areas: context relevance, and which refers to how relevant the retrieve context is to the query, and answer relevance, that refers to how relevant the responses are to the query. To evaluate context relevance, first we select a wide range of prompts to generate a list of queries. Then we create a function to generate context retrieval for all queries. Next, I create a function for evaluating context relevance using our cosine similarity. Cosine similarity is used to measure the cosine of the angle between two vectors. Higher scores indicate a higher relevance of the context to the question. To evaluate answer relevance for each query, we generate a context retrieval and a chatbot answer. Then the answers are evaluated through a human assessment and user feedback. So let's look at the evaluation notebook file. As I said before, first we create a list of queries, then a function for generate context retrieval for each queries. After that, we create a function for evaluating context relevance. That's using cosine similarity. And for answer relevance, we generate context retrieval and a chatbot answer for each query and store them for human assessment. So now let's test our chatbot. In first query, I enter, I want to buy a SUV. As you can see, the chatbot doesn't answer generally to the query and ask personalized question to response more relevant and accurate. Now you can see the chatbot give a result based on our input. For example, we said that full efficiency and finance rate are important for us, and we need a SUV. The chatbot give result and the link for the website. Now let's enter an unrelated query and see how the chatbot responds. So as you can see, our chatbot doesn't answer a relevant question. That's it. Thanks for watching. For more detailed information about AutoBuddy, be sure to visit my GitHub repository link in the description. It contains the fine-tune and evaluation notebook with chatbot Python script. See you in next video.